I'd like to thank you for joining us all this afternoon. Our first speaker here is Dan Hertzberg, who will be presenting Golang for network engineers. Dan is a technical marketing engineer at Arista Networks and is coming at us today from Pittsburgh, Pennsylvania. This is Dan's first time presenting at NANOG. It's a pleasure to have him here speaking, and welcome, Daniel.
Steve. All right, thanks, Steve. Take a step back here. All right, so today we're going to talk about Golang for network engineers. I'm going to have a little bit about this for everyone, I think, who's kind of taking a look at Go and is very interested with it. Kick off with an intro, kind of what exactly Go is. We'll talk about the Go language ecosystem. And we'll have demos, time permitting. Everything within this talk is going to be within my own personal GitHub repo. So burnyd nanog-intro is where you'll find them. We'll hit a couple of different topics with a vendor API and also streaming telemetry if we have time. So Golang in general, also too, just to give a little shout out here, the Go for emoji is probably one of the best marketing terms they've done with Go. It's hilarious. I have plenty of these little plushies at my house. But the way I got interested in Go and the way I got into Go was actually through not even a network technology, but through Kubernetes. So I really like Kubernetes. I kind of fell out of love with networking a little bit in probably 2017, 2016, when Kubernetes came about, and just was looking for something honestly to do. And Kubernetes was really interesting to me. I found Kubernetes to be almost like the second coming of Linux, almost like the second coming of like systemd with a really nice API on top of it written in Go. And I was just really interested in it. Just one of those technologies to me that was just awesome. So I started to learn Go, and then from Go I learned gRPC, and then kind of around the same time, OpenConfig and streaming telemetry started to take off, and it kind of really took interest into that skill set I learned in Go. So that's how I got interested in how it took off with the technology. Go, what is it? I think most people know Go is a programming language, but we'll talk about kind of the selling points of why you should use it and how it works. So Go itself is a simple, compiled, and easy language to read. For myself, it's easy to read. For any newcomers, it's also going to be easy to read just because it is typed. So when I say typed, anything that you work with in Go is a type. So typically, if you're working with VS Code, you kind of hover over an object, it'll tell you if it's a string, an integer, so on and so forth. Go is very quick and it's very efficient. So the compile times in Go are really awesome. So anyone who works with Go typically will tell you like the compile times are one of the best parts about it, just because it's very quick. And Go is designed to run on IoT devices, big servers, laptops, desktops, you name it. Go is cross-compiled in multiple architectures. So when I say cross-compiled in multiple architectures, effectively what that means is you can write Go code on a Linux machine, run it on Windows. You can write Go code on a Darwin MacBook and run it on a Linux AMD 64-bit type of device. So it makes it very easy to use, and the dev cycles are even better in my opinion. Go was developed in 2009, mainly because C was too difficult. I was fortunate enough, or maybe unfortunate enough, to skip learning C. I don't really have much feedback there. But in order for Google to kind of bring in talent and for people to kind of learn more programming languages, Go was created. And Go is pretty easy, and most people will tell you in programming circles. But most of the people who are the developers of Go, or the people who created Go, are mainly kind of old school Unix people. Concurrency is a first-class citizen, so within Go, you get concurrency on top of it almost like for free. So concurrency is the ability to use things called Go routines, which we'll kind of go into in a little bit. And then lastly, honestly, Go, from like most people's opinion, it's just boring. But boring is good. Boring just works. Like, and it's not just me saying this. Like, this is actually one of the founders, Russ Cox, saying this in general, that boring is good, boring is stable. Boring means you're able to just focus on your job. And I can attest to this. I write a lot of Go code. And generally speaking, when I do it correctly, it just works. The features of Go and why you should take a look at it. So Go has a really good package manager system. It's called GoMod. So when you work with Go, or if you're working with a random Go project, for example, you could open up a Go project, look inside GoMod, and see everything that the Go project uses. So whether it uses a specific package, module, so on and so forth. And the same thing goes with the version number. Go uses concurrency and uses Go routines. So these are not the same as threads. Go routines are owned by the Go scheduler, and it kind of does its own thing, but they're even lighter weight than threads. Formatting and whitespacing is really nice. So the way formatting and whitespacing works within Go is that you can kind of go in, no pun intended, create your own code, write up some Go, put tabs, put spaces. You can throw it out of order if you like to, handcraft jam code the way you want to. You do what's called a Go func. It'll put it in the way that it should be. So it'll structure it and make it, as long as it's good Go code, it'll run. Go has built-in unit testing, which is very nice because you don't have to go with any type of domain-specific language, like most places have to have like what's called a DSL, or you go to like a third party, like a PyTest with Python, just for example, for testing. You write Go code against your tests, and as long as those unit tests are good, then the unit tests are good. Package Go dev, which is great. I have yet to be failed by this yet. But package Go dev allows you to look at each one of the Go packages and see all the methods, types, structs, interfaces that are available per package. So errors or values, this is like really important. Most people, when they look at Go, they get kind of annoyed because like they see this like, if error is not the same as nil, do a thing. And it's like all over the place. I couldn't fit this in this particular slide, but effectively the error interface is like 3 lines of code. And as long as you kick up a value for that, it creates an error and you can then kind of break your code or stop the code effectively. Go has generic support, so you'll see a lot of older articles and criticism on Go because it didn't support generics. So if you're not familiar with generics, basically in Go, you'll have types that are the same thing theoretically. So an integer is the same as a uint, which is the same as a int32, int16, so on and so forth. So they support this thing called generics where you can put those in a function and have them come out to be the same thing. And then lastly, it's vendoring packages. So if you start working with a lot of Go code and you get to the point where you kind of take another module, I don't want to say hack it up, but kind of make your own modifications, you do what's called vendoring and keep it internal, and then you kind of own that thing and fork it forever. So the Go use cases of networking, I think this Nanog has been great because I've had so many people come up to me and talk to me about streaming telemetry and GNMI. Like it's been like kind of awesome. So the biggest use case, in my opinion, and these are going to be opinionated bulletin points, but the biggest use case right now is going to be streaming telemetry. So GNMI, I think most people are familiar with, is based off a gRPC service, which has a lot of Go-based clients for it. So it just makes a lot of sense to use a lightweight language like Go to stream all that data back. Infrastructure provisioning is a big use case too. So like Terraform, Pulumi, and Crossplane, all built on Go. And this is opinionated of mine, but effectively the reason why I think that is because most of your cloud providers use typed JSON, so it's very easy to work with. And then lastly, network config management and generation. Unfortunately, there's not a whole lot here. Like Go uses templating. I think a lot of the network automation that is available today is going to be with like Jinja and Python. Go is typed, so it doesn't have that availability to do the sort of Jinja type of thing, but you do have Go templating, which is nice. The one thing I would kind of keep on my radar if I were most people who want to look at Go is something called YGOT. So YGOT was talked a little bit about. There was a slide on Monday during the OpenConfig session. But effectively what it allows you to do is to take Yang schema and break that into Go modules. And once you do that, you can kind of work with the Go modules and you can almost like write code for devices like switches and pure JSON. So it's very interesting stuff. So say you want to get started with Go and you're like, hey, I want to start my first Go project. How do I do it? So Go makes things pretty easy. Like you're going to find throughout this talk, like it's just the ease of the developer experience mostly. Go mod init is how you create a Go module. And then typically what you do is you give it the GitHub repo where it's located. So mine is Bernie D nanog 90 Golang. And you create a file structure after that. The file structure is optional. It's something you can do. You don't have to do. There are certain scaffolding tools that will do this all for you, all in just one binary. But effectively, command is going to be where like the entry point is going to be for Go. So like your main part of your Go package. Package are going to be internal packages. When I say internal packages, those are things like I need my code to have a function or method that reaches out to an external client API. Internal effectively is vendoring. So if you were to get a package that did a certain thing off the internet, made some changes to it, you put that in internal and you vendor that forever. API is going to be where most of your API kind of data model lives. So like you would have either protobufs or you would have JSON tags a little bit in there to talk about the service. And tests is optional. So I've seen some people put tests where they have unit tests within the test directory. And I've seen some people do it to the point where they kind of have tests right next to each individual Go file. Either one works. The package management, this is like kind of one of the really good selling points to Go if you're used to something like, let's say, Python with requirements.txt. I know there's other things like poetry, which I'm actually a fan of, I think is great. But GoMod has this built into it, or Golang has GoMod built into it. What it allows you to do is every single time you type that GoMod in it, you get to this point, and once you start writing code, you start to have requirements. So for example, this module, the name of it's nanoggointro.com. I'm using Go version 120. My direct requirement is Go eAPI. And the interesting part is that the indirect requirement, which means what Go eAPI requires, is map structure and Go ini. So it's kind of easy to follow, and it's not like something like pip or so on and so forth. And also not shown here is the GoSum file, which has the actual checksums to make sure this is the actual modules in which you need. Building with Go is great. Like I said before, the developer experience is really good here, and it's cross-compiled. Like that's like one of the best parts about it. So let's say, for example, you're on a Windows machine, you want to build for Linux. Kind of easy. You take your environmental variable, which is GoOS, you set it to Linux, you take the specific architecture you want to, you do a Go build. And -o flag basically just says what you want the binary to be called. And you end up with this, which is very nice. So if you're working with GitHub Actions, you could automatically have a build for like when you're done with your project to be specific versions and so on and so forth. But it's nice because you don't need name a package -arm, name a package Darwin, Windows.execute, that sort of thing. Go will just do it once and compile once, for the most part. Running and installing with Go. So if you're kind of testing out Go and kind of kicking the tires with it, go run main.go is how you run a Go program like on your system itself. So that'll allow you to just run it. It doesn't compile it, just sort of runs it just in test. Most people have probably seen this, but the Go install portion. And what Go install does, as long as you have your proper Go bin set up, it'll get a Go package off a replicable place, like I call this awesome package. And this will take awesome package and throw this in your path so you could then execute awesome Go package. The unit tests. So like I said before, unit tests are built into Go, like you just have to write them. So essentially all you really do is go test -v, and this will run through the test. So you can see here, this test connect is simply what I called this thing. It passed, yay, hooray, everything is good, and we're happy. If you take the same Go test and you kind of muddy the waters here a little bit, and you change HTTP to not a row transport, which is obviously not valid, you're going to get a failure. So the nice part is that the tests, and we'll show in the demo, is all in Go code. You don't have to know a specific domain-specific language. Error handling. So this is where most people kind of get a little upset with Go, but I completely understand. Most things in Go, function and methods, they always return two things. One thing is going to be a value you typically care about, like a response, and the next thing is going to be an error. So often more than, very, very, very frequently, I'd like to say, you're typically going to do this where it says, if error is not the same as nil, return, do this, print this, do a thing. And you're going to see this all over the place. Like I said before, the error interface in Go is actually really, really simplistic. It's only 3 lines of code, and it's very easy to work with. You just have to be super repetitive on this if error is not the same as nil. Now, getting to the projects that use Go. So pretty much anything within the cloud native computing space uses Go. So if you kind of want to work with the Terraforms of the world, you want to work with Prometheus, you want to work with Grafana, those things are all built in Go. So things like Terraform, you can create your own providers in Go. So I've had experience with that. And it's very good. Their SDK is very good. Prometheus, I think most people have heard of that before. Basically, it's a alerting monitoring system that a lot of people have gotten into the networking space that works out very well. And then Grafana, the integration's also within Go. The two that are like really big, I think, that made a really big splash in the networking field are both Container Lab and GNMIC. So those have done a lot of really good work to get a lot of network people into the both the container space and the OpenConfig space. Because GNMIC, in my opinion, has made things just so easy for the common person to kind of just stream data back and forth. Because GNMI is complex in a way, and I think GNMIC has really done great work to take away a lot of that complexity. And Container Lab, the same thing with Docker, Containerd, and so forth. And obviously, Kubernetes is purely Go written and such. Now, the next slide we're going to get into is OpenConfig. So I think most people kind of have a good idea what OpenConfig is. It's more than just a data structure that goes across, or a schema that goes across different network vendors for modeling and such. There's a whole bunch of projects that are really good and worthwhile checking out. And all these projects are basically gRPC based. If you're unfamiliar with gRPC, it's an API that's multi-languages, but really kind of lends itself very well to Go. Naturally, it works probably best with Go. There's 3 services that are OpenConfig services that are very good and out there in the OpenConfig repositories. I think most people know what GNMI is. So there are GNMI Go clients. Obviously, the binary of GNMI-C is probably the most common one. There's also GNMI clients that are written from Arista and also the OpenConfig community. And basically, GNMI allows you to do specific things to get data off the box and manage your box if you like to. There's extreme cases where you can configure with that with WYGOT, which makes it really cool. Or what most people do is they subscribe to specific paths. The next one is GNOI. There was a GNOI session earlier today. But GNOI is the operations interface, and there's a Go-based client for this as well. But GNOI programmatically allows you to do things like change SSL certs, check BGP neighbors, ping destinations, and even do an upgrade of the OS. Last line here is gRibbie. I'm skipping past some of them that are not on here, like GNSI and bootz and some others, but gRibbie is also really important one. Basically, if you're familiar with gRibbie, programmatically through Go and through the gRPC service, you can dynamically create routes in the form of what they call AFTs. And these things are routes for not only MPLS, but they work with IPv4, v6, and I think even some other encapsulations are on there as well. But the key point is, in order to work with a lot of these things that were given at the Monday presentation, Go is going to be the more or less de facto standard for OpenConfig. There's a lot of popular Go modules out there that, if you work a lot with Python or the languages, these things will work with you as well. So by default, the net HTTP library is really good. Go has a really strong concept there, core of Go modules by default that you typically don't have. If you're doing a very basic thing, like running a web server, you don't need to go out there and get external modules. This makes it really nice. The OpenConfig projects, which are really good, are things like WYGOT. So WYGOT, I have a couple blogs about WYGOT, but WYGOT, like I said before a little previously ago, WYGOT will allow you to write code for devices. When I say write code for devices, you take a Yang schema. So let's say BGP network instances, or let's just say your general interfaces for Ethernet. And you can take that, make that into a Go module, write code for it, get some JSON, and send it off its way through GNMI. So it's very interesting stuff. The miscellaneous ones, which aren't really talked about too much, are Go BGP. So Go BGP allows you to create BGP controllers, BGP neighborships, anything out of BGP. Even EVPN is an address family that's acceptable within Go BGP. The NetAdder Go module allows you to basically verify that things work like IPv4. So is this a valid v4 address? Is this a valid v6 address? What's the next CIDR? That sort of thing. I know there's a common Python NetAdder as well. Prometheus allows you to create Prometheus objects. Go Netbox is pretty interesting because it allows you to talk to Netbox over Go. And then lastly is Go Packet. And Go Packet is a project that's been around for quite some time that allows you to do live packet captures and iterate through the data. So it's pretty interesting. There's a lot of integrations that go with this. Mostly the ones I work with are the top 2. Obviously I work for Arista, so I know most of our gRPC Go implementation. We have a product called Cloud Vision. It's kind of like our management service that gets all the data. We expose gRPC APIs. And with exposing that, we also have gRPC clients that talk to it. It's all written entirely in Go. Equinix has a lot of really good Terraform support. And I could tell they're kind of like all in on Go for the most part, because the Network Edge and the Fabric service are really interesting because they have these really good Terraform providers, but effectively, you can just open up your code editor, import some of these Go modules, and you can create networks like around the world, which I'm still like mind blown in 2024 about that sort of thing. It was really cool. Juniper App Store has a Go SDK, and then Cisco has a Go client that works with ACI and also works with the Nexus OS line. All right, hopefully this works here. This is a quick demo of interacting with a device. So we're going to take the Go eAPI module. What we're going to do is we're connect to a device. We're going to ask a device for a show running config. We're also going to ask the device to give us a show version command. We're going to do that unstructured. And then we're going to get the structured part of it, which will tell us in typing what the MAC address is, what the version number is, and so on and so forth. And then afterwards, we're going to run a unit test. And it seems like we have good enough time here that we can do a quick streaming telemetry demo. So we can see here, we pull on the Go eAPI module. We structure our data like this. So the construct is typically what most people would know what they would structure the data in. So username, password, hostname to connect to a device. And then we initialize D. D is a pointer to con, or well, it's a part of con that we put in all the information. So HTTP, hopefully no one cringes, is not HTTPS. We connect, D.connect. And inside connect, basically what it does is has access to every struct field. So transport host, username, password, and port. And then connect itself returns go eAPI.node or an error if it's not nil. All right, and then what we do is take the running config, which points to connect.runningconfig because running config is a method off of connect. We only do the first 200 lines, by the way. And after that, we take the .enable, which I believe I hover over. Hopefully, yep. Get to enable. In enable, you pass in commands, which is a slice of string, and it returns a slice of map string error. I know it sounds like super repetitive, but it's all typed. All right, and then we just basically range through, we print it out. And next, we're going to show a typed version. So those that worked with eAPI before know that you basically send CLI to it, and it comes back something like this, which gives you a whole bunch of JSON tags with things like version number, free memory, model name, so on and so forth. And once you do that, we start to do this thing called add command. It's just a method that basically queues up the commands. And then we execute call, and that just iterates through everything. But you can see show version, system MAC address, serial number. That is the typing part. That is what makes Go really awesome. I mean, there's many things that make Go really awesome. But when we go run main Go, it'll print this out. And this will all be in the repo if anyone really wants to like play with it. You can see here, it prints out the running config. So it's a massive 200 line of running config. And then we go through the key value pairs. And then we go through a typed version at the very bottom. Next, we'll look at main_test.go. And that has, you'll see in the test portion, mock con. You can see transport HTTP, that all passes, yay, hooray. And then we go with not real, which in flaming defeat here, we could see a big giant fail at the bottom, which means we failed our test. So that would be a good idea of a unit test to actually connect some CLI commands and make sure it works. Because otherwise, you wouldn't want your code to actually run. And since it looks like we have time here, we'll do the GNMI portion. So GNMI, I think most people work with GNMIC. In the repo, it'll give you a good way of doing this programmatically. So those of you who want to kind of take programmatic fashion to kind of see how GNMI works under the covers, this is for you. So like I said before, this is going to be in the repo. But in our main.go file, we're going to import, when I click on it, we're going to import the Arista GNMI package, which just has a bunch of helpers. I mean, you can do the protobuf if you want to. And then we start going with the configuration part of that. So gnmi.config, and we have the target, and we have the port. We could add a lot of fancy other things if you want to in here, if this wasn't a demo, like different compression types and tokens and such. And then paths, we do a slice of string, and that would be our path we'd want to use. And we start to kick off a dialing process. So in GNMI, or well, gRPC, basically you'll see the word dial a lot, and that means just connect to a thing. All right, and then we change some subscription options. So the origin's OpenConfig, and the paths are what I picked for a path. And like I said before, you could change stream and turtle, all kinds of things. This is the interesting part about Go. Basically, anytime you see the word Go, that means kick off a concurrent Go routine. So this Go function, if you look at this and then look at line 35, basically line 35 creates a channel of subscribe response for GNMI. So what's going to happen is this is going to just, error equals means just do a thing, doesn't mean create an error. But basically what it means is create this subscription and fill up response chan with the response channel, or subscribe response. And after we do that, we're going to do a bit of a forever loop until we hit Control-C or Control-Z and just get rid of the program. So you can see here, we switch on specific things. So The response we put in the response channel, and then depending on the type, we do a specific thing. So I think with GNMI, it's subscribe update, or response update. And every time we get that, we do a thing where we just prepend and add and append the time just very easily to a string, just for demo purposes. So we go run main.go. What this is going to do is kick off a gRPC GNMI session. And this is just a container EOS device. It's nothing like, production environment with a lot of traffic on it. But we'll see here, the data actually streams back to the client in real time. And this is all available in that demo repo, but it's really nice to be able to work with something like this that's concurrent, quick, and fast. All right. As far as most people, if Go is something that interests you, like how would you get started with Go? Like what would you? I've talked to a lot of people this week, just in the past 3 days, about Go in general, OpenConfig, and GNMI. But this is just the suggested content and kind of the path I would take if I had to retake the path. Tora Go is completely free, so it's a totally free thing you can go to, no pun intended, that has things like slices, maps, interfaces, strings, how to work with just general Go things. Go by example is another thing. It's rather old. I think Go by example is a couple years old at this point, but it's still extremely relevant. I looked through it the other day just to make sure things are good. Golang Weekly, which is I want to call it a weekly newsletter that you can get. And effectively what Golang Weekly is something that will tell you all the new Go projects. So Go 122 came out February 6th, and I think pretty much everything in Go Weekly has been about the release candidate for 122 and everything about Go 122. And then lastly, network automation with Go. Like if you really found your bindings with Go and you like Go and you think Go is great, and you want to kind of apply everything you learned to your everyday job. Network automation with Go is really good. Past colleague of mine, Michael Cashin, and a good friend of mine, Nicholas Olivia, wrote this book. It's very good. It'll walk you through basic parts of Go, kind of almost like a repetition of what Tora Go is, and then eventually get to the point where you're working with Go templates, OpenConfig, and other network-based functions in general with Go. And I'll take any questions. Thank you.